So let's try this one. We're going to prove that 1 plus sine x over 1 minus sine x equals tan x plus secant x whole thing squared. So this one looks a little bit more difficult. I'm going to start off with that side. So again, I'm going to write it as sine cosine. So I am going to get sine x over cos x equals secant. Plus, geez. 1 over cos x. Whole thing squared. Okay, so can write it as a single fraction because they already have a common denominator, so that part's kind of nice. Sine x plus 1 over cos x whole thing squared. Okay. I guess I could square it out, but I'm not really sure if it would help. I see I already got the sine x plus 1 here, so maybe I want to stop for a second and maybe work on this side, because this already is starting to look like it. So if I work on this side, there's not much I can do, right? It's already got a common denominator because it's already just one fraction. Can't really turn things to the same trig function because they already are. The one thing I can do is a thing that we do with radicals sometimes. We multiply by a conjugate. The reason we like doing that with trig functions also is we do that with radicals because then it squares radicals and gets out of the denominator. Well, with trig functions, having sine squared and cosine squared is pretty damn important. So if I do this, I'll be able to get a sine squared or a cosine squared. So on the top, I'm not going to actually multiply that out because I can kind of see it's going to already look like this. So on the top, I'm going to get 1 plus sine x, which will be squared. On the bottom, I'll FOIL it. 1 plus sine x minus sine x minus sine squared x. So I'll get 1 plus sine x squared over 1 minus sine squared x. So again, hopefully you remember your trig identities. 1 minus sine squared x is going to be the same thing as cos squared x. So 1 plus sine x whole thing squared over cos squared x. And now they do look the same because if I say I don't FOIL it, say I don't multiply the whole thing out, but say I just distribute that to top and bottom, the square to the top and to the bottom, I would get sine x plus 1, which is the same thing as 1 plus sine x over cos squared x. So again, you can work on both sides. You can't move stuff across the equal sign. You can't multiply. You can't do the same thing to both sides of the equal sign. You're just moving with each of the, you're just working individually with each of the sides.